Hi, geometry. I feel like I'm awfully low. Let's try this again. Hi, geometry. Today we're looking at another way to solve any triangle. We've already looked at the law of sines, and we had to pay attention to those special ones called the ambiguous case. Now we're going to look at the other set of options there for any triangle. And one of our options, as we already know, is the law of sines, which is good for angles and that side angle. But today we're going to look at this thing called the law of cosines. So now when I look at the law of cosines, I can do it with side or side angle side. So if I know most of the sides, more than likely I want to use law of cosines. But here's the trick is that side angle side, the angle has to be the one between the two sides, where the side angle, an angle and a side pair are together. So you would have two A's if it's a side angle. You won't have two A's or two B's or two C's if it's a side angle side. So let's look at this real carefully. So law of cosines is what we're looking at. Now as we go down here and we take a look at the actual theorem itself, it says let triangle ABC be any triangle with A, B, and C representing the measures of the sides opposite the angles with measures of angle A, angle B, angle C. So notice the side A will be opposite the angle A, the side B opposite the angle B. Okay, that's what it's telling us. Then the following equations are true. Check these equations out. A squared plus B squared, A squared equals B squared plus C squared minus 2 times B times the cosine of A. Likewise, B squared would equal A squared plus C squared minus 2AC cosine of B. As well as C squared would equal A squared plus B squared minus 2AB cosine C. Now, if we take each one of those equations there, and we solve for the cosine of C or the cosine of B or the cosine of A, we would get these other equations. So the law of cosines, unlike the law of sines, law of sines was you had those three ratios, they all had to be equal. Law of cosine actually is a modification of the Pythagorean theorem. And that's how we would prove that these are actually true statements. So now here we have our triangle ABC. Notice the A's are in red, the B's are in blues, and the C's are in green. These are the 6 different equations that can be used in the law of cosines. You're going to want to get all 6 of them written down. Because here's the way it works, and if we just look at the very last instance there, say we're looking at C's. I would use the cosine of C. So I would use this one if I'm looking for an angle. So if I'm trying to figure out what the cosine or angle A is, or angle B is, or angle C is, I'm going to use those set of formulas. Where if I'm trying to figure out what the side is, I'm using the side formulas. That's the great thing about the law of cosines, is that what I want to find, I isolate on the left. Everything on the right should then have a number in every one of those spots. That's the cool part about the law of cosines. Now, the other thing is we need to be able to identify when we use the law of sines, when we use the law of cosines. So part of the assignment, I think, looks like this. Which method would you be used first to solve the triangle? So problem A is side A is given at 7, angle A is 93, angle B is 47. Problem B, side A is 6, side B is 7, side C is 10. Problem set C, measure of angle R is 60 degrees, side P is 9, side Q is 15. And problem 4, side R is 9, side P is 12, angle R is 30 degrees. So if you want, pause the video, make your prediction on what you would use. LOS is the law of sines, LOC is the law of cosines. Okay, here we go. I have 2 angles. 2 angles, automatic law of sines. Because I know the third angle, I will have a pair. Okay, B, 3 sides. 3 sides, automatic law of cosines, no matter what. Can't do law of sines if all I have are the top numbers of the fractions. So now the other two, I got C and I got D. In both cases, we have two sides and we're given one angle. Two sides and one angle. Now here's what I look for. Is there a combination of letters? I have an R and an R in D. Two R's means I have a full ratio. So this is a law of sines. So this would be one I'd have to check for an ambiguous case on. Okay, now look at the other one. I have no two R's, no two P's. No. Here's the other thing I notice. I've got a P, an R, and a Q. I've got one of each letter, law of cosines. So that's kind of the way to remember. If you're given two angles, automatic law of sines. If you're given three sides, automatic law of cosines. When you're given two sides in an angle, got to look a little closer. Do you have a pair of letters, like we had in D, we had two R's, or do you have three different letters? Three different letters, law of cosines. Two of the same letters, law of sines. So now, let's go ahead and solve A, and I guess it was actually C. No, it was B and C. Right? These are B and C's, basically. Really, that's a B and that's a C. Okay, so law of cosines. I'm given all three sides. All three sides. So that means I want to use one of those cosine formulas. If I'm given all three sides, I really want to use one of these formulas. Now look carefully at those. When I'm looking for the cosine of A, notice it's the A that gets subtracted. But when I'm looking for the cosine of B, notice it's the B that's being subtracted. And A's and B's are in all the other spots. Okay, so there's the basic formula we want to use. So now, on our problem that we have here, I always, for me, when I do law of cosines only, I always want to find the biggest angle first. So when I look at this, since side Q is the longest side, angle Q would be the biggest angle. So cosine of angle Q would have to be R squared plus P squared minus Q squared over 2RP. Now I just plug all the numbers in and see what we get. So I've got 6 squared plus 7 squared minus 10 squared over 2 times 6 times 7. Now I could do it on the calculator. If I do it on the calculator, I need to make sure I put that entire numerator in the parentheses. So I'm not going to do it on the calculator at this moment. 6 squared is 36, 7 squared is 49, 10 squared is 100. 2 times 6 times 7 is 84. 36 plus 49 is 85. 85 minus 15, or 85 minus 100 is a negative 15 over 84. So I've got the cosine of angle Q equaling a negative 15 over 84. Now how do I find the measure of the angle? To find the measure of the angle, I do the inverse cosine. So the inverse cosine of negative 15 over 84 would be what I would look for. So inverse cosine of that value gives me 100.3 degrees, rounded to the nearest tenth. So I now know angle Q. Remember, we're solving the triangle, which means I have to find the measure of angle Q. So that's 100.3. I have to find the measure of angle R. I have to find the measure of angle P. So now I'm at a point where I have both Q's, so I could use the law of sines to find my next angle. Or, since I have all three sides, no rounded numbers, I would say use the law of cosines again. So here I went through all that work to find angle Q. I could repeat that process and do it for one of the other angles. So, like I say, I would like to find the biggest one first. So P would be my next angle. So the cosine of angle P would be R squared plus Q squared minus p squared over 2r cubed. So that would mean it's 6 squared plus 10 squared minus 8 squared, 7 squared over 2 times 6 times 10. Well, on the bottom, that's 120. On the top, I got 36 plus 100 minus 49. So 51 and 36 is 87. Sound right? Yep, 87. So the cosine of angle P is 87 over 100. So that means the measure of angle P is the inverse cosine of 87 over 120. So the inverse cosine of 87 divided by 120 is 43.53. So 43.5 degrees. So 43.5 degrees. So now I have V, angle P at 43.5, A at 100.3. I'm going to go ahead and add those two together. And when I add those two together, I get 143.8. So if I subtract 180, or subtract that from 180, I get 36.2. So there are my measures for that one. So when I have all three sides, I really want to use the law of cosines and run it through those cosine angle equals, those pairs, and they work out real nice. Now look at the other one. I have a Q, a P, and an angle R. Let's go ahead and move this to another spot. Oops, that didn't. Okay, give us more room to work with here. So if I have those three bits of information, what I'm missing is side R, don't know it, and I don't know the measure of angle Q, and I don't know the measure of angle P. So we have to find three items. Again, we're given three items, got to find three items. Since I don't know side R, that's the one I'm missing, that's the formula I want to use. So R squared would have to equal P squared plus Q squared minus 2PQ times the cosine of angle R. That's our formula just modified, the A, B's, and C's. So now I plug in the numbers I know. I know 9 squared plus 15 squared minus 2 times 9 times 15 times the cosine of 60 degrees. Now what I do is I plug this whole thing straight into the calculator. So 9 squared plus 15 squared minus 2 times 9 times 15 times cosine 60. I put it all in the calculator. And it tells me that R squared is 171, which means R is the square root of 171, which is around 13.1. Around 13.1. Okay, so now I need to figure out what angle Q and angle P are. Again, what I'd like to do is find the largest angle possible for me. Other places, if you read it, and they'll say, okay, you go to the law of sines next, and you find the smallest angle, so that way you don't have to worry about the ambiguous case and getting something that's not right. But for me, if I'm going to use the law of cosines, I want to use the law of cosines. I know the exact value for R. You know, right here, we have the exact value for R. So we could use it in our calculations. So for me, I wouldn't go to law of sines, but we could. We could do 9 over the sine of P equals, and now I have to use that R, the square root of 171. I want to use the most accurate number over the sine of 60. So that's what we want to do. We want to solve this. And the angle P would have to be at the smallest angle because side P is the smallest side. And that's why if I'm going to do the law of sines after the law of cosines, I want to go after the smallest angle. If I'm going to use the law of cosines after the law of cosines, I always go after the biggest angle. So now all I got to do is solve this. So to solve this, I would take 9 times the sine of 60, because that would be if I was cross multiplying, and then I would multiply by the other number, so I would divide that by the square root of 171, and that's going to get me the sine of angle P. So 9 times the sine of 60 divided by the square root of 171. I want to use that whole number if possible. So this gets me 0.596039, on and on and on and on, is my sine of angle P. So now to figure out what the measure of angle P is, I have to do the inverse sine, or the arc sine, of our number there. That was a 9. Of 0.5960, da 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 da. I want to use that whole thing. So inverse sine that value, and I get 36.58677, on and on and on. So I would say angle P is around 36.6 degrees. So now that I have an angle P and an angle R, I already know I'm pretty close to having this whole thing done. So if I add the 60 degrees from that and I subtract that value then from 180, I find out that Q is 83.4 degrees. So, trick here is, law of cosines is used if I'm given all three sides or a side angle side. So because it says side angle side, that means I have one of each letter, which works really well. Then, after I know that I'm using the law of cosines, I figured out which of the formulas would best help me out. For me, when I'm giving all three sides, I always look for the biggest angle first, which is going to be opposite the largest side. And then I can like to continue using that. But you can go to the law of sines after you do the law of cosines. If you do the law of sines, then look for the smallest side. Okay, that is this information.